Hello and welcome to Wood Station. Today we're going to be talking about Newton's laws of motion. So Newton's first law says that a body at rest stays at rest, or if moving, continues to move at a constant velocity unless an unbalanced force acts upon it. So we'll take this in two parts. So we'll take first of all, a body at rest stays at rest unless an unbalanced force acts upon it. So if we think about a ball, if you have a ball sitting on the ground, it'll stay on the ground unless an unbalanced force acts on it. Now, this unbalanced force could be you kicking it, or it could be the wind moving it, or it could be an animal coming up and eating it, for example. So that's the first part of that. A body at rest stays at rest. So if it's not moving initially, it'll continue not to move until an unbalanced force acts upon it. So the second part of this says if a body is moving, it continues to move at a constant velocity unless an unbalanced force acts on it. So if I were to kick this ball, it would continue to sort of roll at a constant velocity. But we know from real life that it won't roll forever. It'll eventually slow down. And that's due to the frictional forces that are acting on it. So you've got the friction from the ball against the ground. And then you've also got things like air resistance. So essentially that's Newton's first law of motion. The second law states that the acceleration of an object is inversely proportional to its mass and proportional to the force acting upon it. So if we write this out, so if we say that the acceleration of an object is inversely proportional to its mass first, that's going to be acceleration is inversely proportional to mass. Then we're also going to have that acceleration is proportional to force. So from this, you can do a bit of jiggery pokery with the equations, but you essentially end up with force is equal to mass times acceleration. So what we would have had from the two equations would have been A is equal to something over m, and it's going to be proportional to F. So A would be equal to force over mass. So if acceleration is equal to force over mass, then force is equal to mass times acceleration, which is the way I prefer to look at it. And that's Newton's second law of motion, and we end up using that equation an awful lot just because it's dead useful for answering questions. So if we look at that equation for a little bit, let's say force is equal to mass times acceleration, and we're going to say that mass is measured in kilograms, acceleration is meters per second squared. This means that force is measured in kilograms, kilogram meters per second squared, which is also equal to Newton. So those are just the base units for newtons. Okay, so the third law, if body A exerts a force on body B, then body B exerts a force the same size on body A, but in the opposite direction. So essentially, this is every action has an equal and opposite reaction, where if you have a block sitting on the ground, then that block is going to be exerting a force which is equal to the mass times the acceleration due to gravity on the ground. So that's the force due to the mass, or the weight. So if the laws of motion, if this wasn't the law of motion, then that weight could continue just to form the floor until it sort of falls through and just ends up going straight to the surface. However, there's an equal and opposite force acting on the block, and that is what I like to call the contact force, and that's just going to be equal to the negative of the force going down. So it's equal and opposite. So this is noticeable in lots of things. Essentially, well, it's noticeable everywhere, as all the laws are noticeable everywhere. But if you have a uniform rod, for example, and the weight is right through the middle of the pivot, then there is going to be a contact force which is equal to the weight going down. Okay, and that occurs in moments, and that's often something that you have to account for, especially if you have a moment with two pivots, and you're looking for when if say the question asks you to look for how much weight was needed on this side to unbalance the pivot, you'd be looking for the point where this contact force was equal to 0, because then it would start to become unbalanced as soon as it left this point, and that's a question that you might get asked in mechanics and maths. Don't know if they ask it in AS physics, but it's useful to know. So that's essentially Newton's laws of motion summed up. If you have any questions, do let me know. Thank you.